do you know why space is truly horrifying? Not just scary in a fun way, but genuinely, deeply terrifying in ways that should make us question everything we think we know about our place in the universe. Most people look up at the stars and feel wonder, maybe a sense of adventure. But today, I'm going to show you why space is actually the most horrifying thing we've ever encountered. And trust me, by the end of this, you'll never look at the night sky the same way again. The silence that screams. Let's start with something simple. Space is silent. Completely, utterly, absolutely silent. And I don't mean quiet like a library. I mean silent in a way that your brain literally cannot comprehend because you've never experienced true silence in your entire life. Think about it. Right now, wherever you are, you can hear something. Maybe it's traffic outside, maybe it's the hum of your refrigerator, maybe it's your own breathing. Your ears have never stopped working since the day you were born. Even in the quietest room you've ever been in, you could hear your heartbeat, the blood rushing through your ears, the tiny movements of your own body. But in space, nothing. If you screamed as loud as you possibly could, you wouldn't hear a single sound. Not because you're deaf, but because there's literally nothing to carry the sound waves. No air, no molecules, nothing. You could watch the most violent explosion happen right in front of you, something that would shatter your eardrums on Earth, and you'd hear absolutely nothing. Just silence. Now imagine floating out there in that silence. You can't call for help. You can't hear danger approaching. You can't even hear yourself think in the way you're used to because the sound of your own voice is gone. It's a kind of sensory deprivation that humans were never meant to experience. And this silence stretches across billions and billions of miles in every direction. The entire universe is screaming in silence, and we're just tiny creatures who happen to evolve on one of the few places where sound exists. The void that never ends, but the silence is just the beginning. Let's talk about the emptiness. The sheer, mind-breaking emptiness of space. You know how sometimes you'll be driving on a long highway and feel like you're in the middle of nowhere? Or maybe you've been out on the ocean and couldn't see land in any direction. That feeling of being far from home, far from safety. Take that feeling and multiply it by infinity. That's space. The distance between Earth and the Moon is about 240,000 miles. That seems like a lot, right? It would take you years to walk that distance. But in space terms, that's like being in the same room. The Moon is our closest neighbor, and we're practically touching it compared to everything else out there. The nearest star to us, Proxima Centauri, is about 4.24 light-years away. That means if you could travel at the speed of light, which is 186,000 miles per second, it would still take you more than 4 years to get there. And traveling at the speed of light is impossible. With our current technology, it would take tens of thousands of years to reach even our nearest stellar neighbor. But here's where it gets really terrifying. That's just the nearest star. Our galaxy, the Milky Way, is about 100,000 light-years across. There are somewhere between 100 to 400 billion stars in our galaxy. And our galaxy is just one of an estimated 2 trillion galaxies in the observable universe. Let me put that in perspective. If you were floating in space somewhere random in our universe, the chances that you'd be within a billion miles of anything at all is basically zero. You'd be surrounded by emptiness in every direction for distances so vast that your mind can't even process them. You could pick a direction and travel at the speed of light for millions of years and still be in the middle of nothing. The universe is so mind-bogglingly enormous that we are less than a grain of sand on all the beaches of Earth. We're less than an atom in the entire planet. We're so small and the universe is so big that it makes our existence seem almost impossible. Almost like a mistake. The cold that burns. Now let's talk about the temperature. Or rather, the complete absence of it. Space is cold. But not cold like winter. Not cold like the Arctic. Cold in a way that would kill you in seconds. The average temperature of space is about -455 degrees Fahrenheit, or about 2.7 Kelvin. That's just barely above absolute zero, the coldest temperature physically possible in our universe. What happens to a human body at that temperature? Well, first, any exposed moisture would instantly freeze. Your eyes, your mouth, your lungs if you were foolish enough to hold your breath. The water in your cells would begin to freeze, expanding and rupturing the cell walls. Your blood would thicken and slow. But here's the really twisted part. You wouldn't actually freeze solid immediately like in the movies. Why? Because freezing requires heat to be transferred away from your body, and in the vacuum of space, there's nothing to transfer it to. No air to conduct the heat away. Instead, you'd lose heat slowly through radiation, which would actually take a while. So you'd be dying from multiple things at once. The cold, yes, but also the lack of oxygen, the pressure difference, the radiation. Your body would shut down system by system, and you'd be conscious for at least 15 seconds of it. 15 seconds of knowing you're dying in the most hostile environment imaginable, surrounded by infinite emptiness and silence. And the worst part? In most of space, there's no one to hear you, no one to see you, no one to save you. You would just drift, slowly freezing, for eternity. Your body would become another piece of space debris, floating through the void forever. The pressure that isn't there. Let's talk about what happens to your body in a vacuum. This is where space gets really personal, really invasive, really horrifying. Your body right now is under about 14.7 pounds per square inch of atmospheric pressure. That's the weight of all the air above you pressing down on every part of your body. You don't notice it because you've lived with it your entire life, and your body is designed for it. The pressure inside your body matches the pressure outside. But in space, there's no pressure. None at all. It's a perfect vacuum, or as close to one as exists naturally in our universe. So what happens when you suddenly remove all that external pressure? Your body doesn't explode like in some movies, but something arguably worse happens. The pressure inside your body suddenly has nothing to push against. First, the air in your lungs would expand rapidly. If you held your breath, your lungs would rupture. That's why the first rule if you're ever exposed to vacuum is to exhale. Let all the air out of your lungs as fast as possible. Then the water in your body would start to boil. Not because it's hot, but because in a low-pressure environment, water boils at lower temperatures. The water on your tongue, in your eyes, just under your skin would begin to vaporize. You'd swell up to maybe twice your normal size as the water vapor formed bubbles in your tissues. Your blood wouldn't boil because your circulatory system is a closed-pressure system, but the oxygen in your blood would be depleted in seconds. You'd lose consciousness in about 15 seconds from lack of oxygen to the brain. You'd die in about 2 minutes. But those 2 minutes? They'd be agony. The feeling of your body swelling, your moisture evaporating, your lungs desperate for air, all while floating in infinite darkness and silence. It's a death so alien, so far removed from anything humans evolved to experience, that it almost seems designed to be maximally terrifying. The radiation that kills slowly if the immediate dangers of space weren't enough. Let's talk about something that would kill you even if you had a perfect spacesuit with unlimited oxygen and perfect temperature control. The radiation. On Earth, we're protected by two things: our atmosphere and our magnetic field. These two shields protect us from the constant bombardment of radiation from the sun and from deep space. Cosmic rays, solar wind, gamma rays, X-rays, all of it gets filtered out or deflected before it reaches us. But in space, you have no protection. You're exposed to all of it. Solar radiation alone would give you a lethal dose in a matter of days without proper shielding. But that's not even the scariest part. The scariest part is cosmic rays. Cosmic rays are high-energy particles, mostly protons, that travel through space at nearly the speed of light. They come from supernovas, from black holes, from the most violent events in the universe. And they're constantly passing through space in all directions. When a cosmic ray hits you, it doesn't just damage the surface of your body. It passes right through you. It can tear through your DNA, causing mutations that lead to cancer. It can kill brain cells. If you're unlucky, a particularly energetic cosmic ray could hit a critical part of your brain and cause immediate damage. Astronauts on the International Space Station, which is still protected by Earth's magnetic field, report seeing flashes of light even with their eyes closed. These are cosmic rays passing through their eyeballs, exciting the cells in their retinas. Imagine trying to sleep while your eyes are randomly flashing with light from particles that have traveled across the galaxy to pass through your body. On a trip to Mars, which would take about 7 months with current technology, astronauts would be exposed to radiation levels about 300 times higher than on Earth. That's enough to significantly increase their cancer risk and potentially cause brain damage. And that's just traveling within our solar system, where we still have some protection from the sun's magnetic field. Go beyond that, into interstellar space, and the radiation gets even worse. Any trip to another star system would require shielding so heavy that our current spacecraft couldn't lift it. The crew would almost certainly develop cancer, might experience brain damage, and would probably die before reaching their destination. The universe is actively hostile to life. It's bombarding us with deadly radiation constantly, and the only reason we've survived is because we happen to evolve on a planet with the right protections in the right place. The speed that makes no sense. Let's talk about something that sounds exciting but is actually terrifying. The speeds at which things move in space. Right now, you're sitting still, right? Wrong. You're on Earth, which is rotating at about 1,000 miles per hour at the equator. You don't feel it because everything around you is moving at the same speed. But that's just the beginning. Earth is also orbiting the Sun at about 67,000 miles per hour. The Sun is orbiting the center of the Milky Way galaxy at about 514,000 miles per hour. And the Milky Way itself is moving through space at about 1.3 million miles per hour relative to the cosmic microwave background radiation. Add all that up, and you're moving through space at over 1 million miles per hour right now. You're not sitting still. You've never been still. You can't be still because there's no such thing as still in space. Everything is moving, always, at incomprehensible speeds. And here's where it gets terrifying. If you're in a spacecraft in deep space and something goes wrong, there's no friction to slow you down. You'll keep moving at whatever speed you were going forever. If you get knocked off course, there's no way to just stop and figure out where you are. You're going to keep drifting in whatever direction you were pushed until you hit something or get caught by something's gravity. And space is full of things moving at these incredible speeds. Asteroids, comets, even tiny particles of dust. A paint fleck moving at orbital speeds hit a space shuttle window once and created a quarter-inch pit in the glass. A paint fleck. Now imagine something the size of a pebble hitting your spacecraft at 10,000 miles per hour. It would punch through your hull like it wasn't even there. It would kill everyone inside instantly. And you'd never see it coming because space is too big and these objects are too small and too fast. There are millions of pieces of space debris orbiting Earth right now. Old satellites, rocket parts, fragments from collisions. Each one is moving at thousands of miles per hour. Each one is a potential bullet that could destroy a spacecraft. And we can only track the larger pieces. The smaller ones, the ones that are still big enough to kill you, are invisible until they hit. The speeds in space are so fast and the distances are so vast that one small mistake, one tiny miscalculation, can send you drifting off into the void forever with no hope of rescue. The loneliness that breaks minds. Now let's talk about something that doesn't kill your body but might destroy your mind. The absolute, crushing loneliness of space. The farthest any human has been from Earth is about 248,655 miles. That was the crew of Apollo 13 when they swung around the far side of the moon. For a brief time, they were the most isolated humans in history. Not only were they farther from Earth than anyone had ever been, but when they passed behind the moon, they lost all radio contact. They were completely cut off. For about 25 minutes, they couldn't talk to anyone. They couldn't call for help. They couldn't even know if Earth still existed. One of the astronauts later said it was the most alone he'd ever felt. And that was just 25 minutes, and they knew they were coming back. Now imagine being on a trip to Mars. At its closest, Mars is about 34 million miles from Earth. At its farthest, it's about 250 million miles away. Radio signals travel at the speed of light, which means a message from Mars would take between 3 and 22 minutes to reach Earth, depending on where the planets are in their orbits. That means if you asked a question, it would take 6 to 44 minutes to get a response. You couldn't have a conversation. You couldn't call home if you were scared or needed help. Any emergency would be something you'd have to handle alone because by the time Earth knew about it and could respond, you'd already be dead or have solved it yourself. And that's just Mars. A trip to Jupiter would have communication delays of up to 50 minutes each way. Saturn. Over an hour. And those are still in our own solar system. If humans ever try to reach another star system, the loneliness becomes absolute. A message to Proxima Centauri would take over 4 years to get there and another 4 years for a response. That's 8 years minimum for a 2-word exchange. The crew would be completely on their own. They couldn't get advice, couldn't get help, couldn't even get comfort from home. They'd be more isolated than any humans in history. And think about what that does to a person's mind. Humans are social animals. We evolved in groups. We need connection, need community, need to feel like we're part of something larger than ourselves. Isolation is literally a form of torture. Prisoners in solitary confinement often develop severe psychological problems in just weeks or months. Now imagine years of isolation. Decades. Knowing that everyone you've ever known is so far away that you'll never see them again. That any message you send might be received by their grandchildren. That you're traveling through an empty, hostile void where nothing lives, where nothing can live, where nothing human has ever been or ever will be again. The loneliness of space isn't just physical distance. It's existential. It's the knowledge that you're leaving behind everything that makes you human, everything that connects you to the human experience, and venturing out into a universe that doesn't care if you live or die. The darkness that hides everything. Space is dark. Really, truly dark in a way that's hard to comprehend. On Earth, even on the darkest night, there's some light. Starlight, moonlight, the glow of distant cities. Your eyes never experience true, complete darkness unless you're in a cave or a room with no windows. But in space, away from stars, the darkness is absolute. If you turned off the lights on your spacecraft, you wouldn't just be unable to see. You'd be in a darkness so complete that your eyes would create false images, phantom shapes, trying to make sense of the total absence of light. And here's what makes that terrifying. Space is so big that most of it is dark. Yes, there are billions of stars, but they're separated by such vast distances that most of space is empty darkness. If you could stand in an average random spot in the universe, you'd see maybe a handful of stars, if any. You'd be surrounded by darkness in all directions. But it's not empty darkness. That's the really frightening part. The darkness is hiding things. Asteroids, comets, rogue planets, failed stars called brown dwarfs. Things that emit no light of their own and reflect almost nothing. Things that could kill you if you hit them, and you'd never see them coming. In 2017, scientists discovered an object passing through our solar system from interstellar space. They named it Oumuamua. It was the first interstellar object we'd ever detected. But here's the disturbing part. We only saw it because we got lucky. It passed close enough to the sun that it reflected a tiny bit of light, and we happened to be looking in the right direction at the right time. How many other objects like that pass through our solar system without us ever knowing? How many things are moving through the darkness between stars, invisible, undetectable, carrying who knows what? And on a larger scale, most of the universe is literally invisible to us. Scientists estimate that about 85% of the matter in the universe is dark matter, something that doesn't emit, absorb, or reflect light. We can only detect it by its gravitational effects on things we can see. It's all around us, passing through us, and we have no idea what it is. The universe is mostly made of something we can't see, can't touch, can't detect directly. We're floating through an ocean of invisible matter in a cosmos that's mostly empty darkness, and anything could be lurking in that darkness. The time that breaks reality. Now we need to talk about time, because space doesn't just mess with distance, it messes with time itself. And this is where things get really, deeply weird and terrifying. Einstein showed us that time isn't constant. It moves at different speeds depending on how fast you're going and how strong the gravity is around you. This isn't science fiction. This is proven, measured, real physics. If you travel very fast, time slows down for you relative to people who aren't moving as fast. If you're near a very strong gravitational field, time slows down for you compared to people farther away from that gravity. Astronauts on the International Space Station age slightly slower than people on Earth. We're talking milliseconds over months, but it's real and measurable. They come back to Earth a tiny bit younger than they would have been if they'd stayed on the ground. Now imagine traveling at a significant fraction of the speed of light. At 90% the speed of light, time would be moving about twice as slow for you as for someone on Earth. A journey that takes you 10 years would see 20 years pass on Earth. At 99.9% the speed of light, time dilation becomes extreme. 1 year for you could be decades for Earth. You could leave Earth as a young person, travel to a nearby star, and return to find that everyone you knew is dead. Your children would be older than you. The world would have changed beyond recognition. This is called the twin paradox, and it's not a paradox at all. It's real. If we ever develop the technology for relativistic space travel, anyone who uses it will be stepping into a time machine that only goes one direction: forward. But here's where it gets existentially horrifying. At the extreme, near a black hole, time can slow down so much that it essentially stops. If you could somehow survive near the event horizon of a black hole, looking back at the universe, you'd see time speeding up. Stars would be born and die in seconds. Galaxies would collide and merge. The entire future of the universe would play out before your eyes. And if you fell into the black hole, from your perspective, you'd hit the singularity in finite time. But from an outside observer's perspective, you'd never actually fall in. You'd appear to freeze at the event horizon, gradually redshifting until you faded from view. You'd be stuck, frozen in time forever, from the outside looking in. Time and space isn't just relative. It's breakable. And that means that anyone traveling in space has to confront the fact that they're not just traveling through space, they're traveling through time in ways that could separate them forever from everything and everyone they've ever known. The emptiness between atoms. Let's zoom in now and talk about something that makes space even more disturbing. The emptiness isn't just out there between stars. It's in everything, including you. An atom is mostly empty space. If you scaled up an atom so that the nucleus was the size of a basketball in the middle of a football field, the electrons would be tiny gnats buzzing around in the stands. Everything in between is empty. You are mostly empty space. The chair you're sitting on is mostly empty space. Everything you've ever touched, everything you've ever seen, everything that exists is mostly nothing. The only reason matter feels solid is because of the electromagnetic forces between atoms. The electrons in the atoms of your hand repel the electrons in the atoms of the table, creating the sensation of solidity. But there's no actual contact. No part of you has ever actually touched anything. You've just gotten close enough for the forces to push back. In a very real sense, you're already in space. You've always been in space. You're a collection of atoms, each mostly empty, held together by forces, floating in an empty universe. And here's where it gets really trippy and terrifying. Quantum mechanics tells us that even the particles that make up atoms aren't really solid things. They're more like probabilities, waves of potential existence that only solidify into particles when we observe them. At the most fundamental level, nothing is real in the way we think of as real. Everything is quantum foam, probability distributions, empty space with occasional knots of energy that we perceive as matter. The emptiness of space isn't just out there. It's in here. It's everywhere. It's everything. You're a temporary pattern in an ocean of nothing, and someday, the pattern that is you will dissolve back into the void, just like everything else. The forces that could kill us all. Now let's talk about the threats that exist in space, the things that could end human civilization in an instant, and we'd never see them coming. First, asteroids. There are millions of asteroids in our solar system, ranging from pebbles to dwarf planets. Most of them are in the asteroid belt between Mars and Jupiter, but some have orbits that bring them close to Earth. About 66 million years ago, an asteroid about 6 miles wide hit Earth. The impact released energy equivalent to billions of nuclear bombs. It created a crater over 100 miles wide, triggered earthquakes and tsunamis, and threw so much debris into the atmosphere that it blocked out the sun. The dinosaurs and about 75% of all species on Earth went extinct. Could it happen again? Absolutely. We're constantly discovering new near-Earth asteroids. Some of them have orbits that will bring them very close to Earth. And by close, I mean within a few million miles, which in space terms is like a bullet passing an inch from your head. In 2013, a meteor about 65 feet in diameter exploded over Chelyabinsk, Russia. Nobody saw it coming. It released energy equivalent to about 30 Hiroshima bombs and injured over 1,500 people from broken glass and debris. And that was a small one. There are asteroids out there big enough to destroy a city, destroy a country, or even end human civilization. And we don't know where all of them are. We're getting better at tracking them, but we don't have a comprehensive catalog. Something could be heading toward us right now, and we might not know until it's too late to do anything about it. But asteroids aren't even the scariest threat from space. Let's talk about gamma-ray bursts. A gamma-ray burst is the most energetic event in the universe besides the Big Bang itself. They happen when massive stars collapse into black holes, or when neutron stars collide. For a few seconds, a gamma-ray burst releases more energy than our sun will emit in its entire 10 billion-year lifetime. If a gamma-ray burst happened within a few thousand light-years of Earth and was pointed in our direction, it would be catastrophic. The gamma rays would strip away our ozone layer, exposing the surface to deadly solar radiation. It would trigger climate change, cause mass extinctions, and potentially end complex life on Earth. And we'd have no warning. Gamma rays travel at the speed of light. The first indication we'd have that one was happening would be when it hit us. We'd see the flash, and by the time we saw it, it would already be over. Has it happened before? Possibly. Some scientists think a gamma-ray burst might have caused the Ordovician extinction event about 450 million years ago, which killed 85% of all species on Earth. Could it happen again? Absolutely. In fact, there's a star called Eta Carinii about 7,500 light-years away that's a candidate to produce a gamma-ray burst. It's one of the most massive and unstable stars we know of. When it goes, and it will go sometime in the next million years, it might be pointed at us. Then there are solar flares and coronal mass ejections from our own sun. In 1859, the largest solar storm ever recorded, called the Carrington event, hit Earth. It was so powerful that it caused telegraph systems to fail and in some cases catch fire. Auroras were seen as far south as the Caribbean. If a storm like that hit us today, it would be devastating. Our entire civilization depends on electricity and electronics. Satellites would be fried. Power grids would collapse. Communications would fail. Modern society would grind to a halt, and it could take years to rebuild. And the worst part? We can see solar storms coming, but we can't do much to stop them. We'd have maybe 12 to 18 hours warning for a big one. That's not enough time to protect everything. Space is constantly trying to kill us. Asteroids, gamma-ray bursts, solar storms, rogue black holes, hypervelocity stars ejected from other galaxies. We're living on a small, fragile planet in the middle of a cosmic shooting gallery, and it's only a matter of time before something hits us. The questions we can't answer now. Let's talk about the things about space that we don't understand. Because in many ways, what we don't know is more terrifying than what we do know. We've already mentioned dark matter. About 85% of the matter in the universe is made of something we can't see or detect directly. We know it's there because we can see its gravitational effects, but we have no idea what it is. It could be particles we haven't discovered yet. It could be something completely outside our current understanding of physics. It's all around us, and we're clueless. Then there's dark energy. The universe isn't just expanding, it's expanding faster and faster. Something is pushing space itself apart, accelerating the expansion. We call it dark energy, but that's just a name for our ignorance. We don't know what it is. We don't know why it exists. We don't know what it's going to do. Current estimates suggest dark energy makes up about 68% of the universe. Dark matter is another 27%. That means everything we can see, everything we've ever studied, everything we think of as the universe is only about 5% of what's actually out there. We understand 5% of the universe. We're guessing about the other 95%. Think about how terrifying that is. Imagine if you could only see 5% of the room you're in, and the other 95% was invisible to you, but you knew it was there because things were moving as if something invisible was pushing them. You'd be terrified, right? That's where we are with the universe. And then there are the big questions. What happened before the Big Bang? Did time even exist before the Big Bang? Is our universe the only one, or are there others? If there are other universes, can we ever reach them or even detect them? We don't know. We have theories, hypotheses, Guesses based on mathematics that might or might not have any connection to reality. But we don't know. Here's a terrifying thought. What if the laws of physics aren't the same everywhere in the universe? What if there are regions of space where the fundamental constants are different? Where the speed of light is faster or slower? Where gravity works differently? We assume the laws of physics are universal because they seem to be the same everywhere we can observe. But we can only observe a tiny fraction of the universe. What if there are parts of it that work in ways we can't even imagine? And what's outside the observable universe? The universe is bigger than the part we can see, because light from the most distant parts hasn't had time to reach us yet. What's out there in the parts we can't see? Could there be things so alien, so different from anything in our corner of the cosmos that we wouldn't even recognize them as real? The universe is full of mysteries, and many of them might be unsolvable. Not because we're not smart enough, but because we're fundamentally limited by our position in space and time. We're like ants trying to understand quantum mechanics. Some things might just be forever beyond us. The possibility we're alone now. Let's talk about something that's either comforting or absolutely terrifying depending on how you look at it. The Fermi paradox. The Fermi paradox is simple. If the universe is so big and so old, where is everyone? There are billions of stars in our galaxy alone, and many of them are older than our sun. If life can develop on planets around stars, and if even a tiny fraction of that life becomes intelligent and technological, then there should be thousands or millions of advanced civilizations in our galaxy. Some of them should be millions of years more advanced than us. They should have spread across the galaxy. They should have built structures we could detect. They should have sent signals we could pick up. But we found nothing. No signals, no structures, no visitors, no evidence that anyone else is out there or has ever been out there. This is the Fermi paradox, and there are really only a few possible explanations. 1. We're first. We're the first intelligent technological civilization to arise in our galaxy. This seems unlikely given how old the galaxy is, but it's possible. 2. We're alone. Life is so rare, or intelligent life is so rare, that we're the only ones in our galaxy or possibly in the entire observable universe. This is cosmically lonely and puts a terrifying amount of responsibility on us as the only witnesses to the universe. 3. They're out there but we can't detect them yet. Maybe civilizations don't last long enough to spread across the galaxy. Maybe they destroy themselves with war or pollution or AI. Maybe they get hit by asteroids or gamma-ray bursts before they can become spacefaring. Maybe the universe is full of ruins of civilizations that didn't make it. 4. They're out there and they're quiet on purpose. Maybe any civilization that broadcasts its presence gets destroyed by something else out there. Maybe there's some kind of predator civilization that hunts down any species that makes noise, so everyone else has learned to stay silent. 5. They're so advanced we can't recognize their technology or communications. Maybe what we think is a natural phenomenon is actually an alien megastructure or communication system, and we just don't have the knowledge to recognize it. 6. They've been here and we don't know it. Maybe Earth has been visited before, millions of years ago, and any evidence has eroded away. Maybe they're here now and we can't see them because they're in a different dimension or using technology we can't detect. Each of these possibilities is disturbing in its own way. Either we're alone, which is existentially terrifying, or we're not alone but something is preventing us from making contact, which might be even more terrifying. The universe is big enough and old enough that it should be teeming with life. The fact that it seems empty suggests that something is very wrong. Either life is far rarer than we think, or something happens to civilizations that prevents them from lasting or spreading. There's even a hypothesis called the Great Filter, which suggests that there's some stage in the development of life that's nearly impossible to get past. Either we've already passed it, which would explain why we don't see anyone else, or it's still ahead of us, which means we're probably doomed. The silence of the universe is deafening, and we don't know what it means. The reality of death in space. Let's get visceral for a moment and talk about what actually happens when people die in space, because it's not like in the movies. On Earth, when someone dies, their body decomposes. Bacteria break down the tissues, insects help the process along, and eventually the body returns to the soil. It's natural, it's part of the cycle of life. In space, that doesn't happen. There are no bacteria in space. No insects. No decomposition in the way we think of it. If you died in space in a spacesuit, your body would be preserved for a very long time. The cold would essentially freeze-dry you. The lack of oxygen would prevent most decay. You'd become a mummy, floating in the void forever. If you died in a spacecraft, it's more complicated. If the temperature was maintained, your body would start to decompose from the bacteria already in your body, but it would be a slow, strange process without oxygen. You'd essentially rot from the inside out. The smell would be unbearable for any survivors. And here's a dark reality. Space agencies have plans for what to do with bodies. On a long mission to Mars, if someone dies, you can't exactly bury them or send them home. The body would have to be stored somehow, probably frozen, for the entire trip. Imagine being on a spacecraft for months with a frozen corpse. Some scientists have proposed that bodies could be freeze-dried and turned into a kind of powder that could be disposed of or brought home more easily. Others have suggested burial in space, just jettisoning the body to drift forever. But think about what that means. If humans become a spacefaring species, many of us will die out there. Some will die in the void between planets. Some will die on alien worlds. Some will die in spacecraft accidents. And unlike on Earth, where our bodies return to the planet and new life grows from them, in space we'll just float. Forever. Frozen monuments to our ambition and fragility. Ghost ships with dead crews will drift through the solar system, possibly for millions of years. There's something deeply unsettling about death in space. On Earth, death is part of the cycle. Your body feeds other life. You return to nature. But in space, you don't return to anything. You just exist, preserved in the cold, silent void, until eventually you fall into a sun or drift out of the solar system entirely. The perspective that changes everything. Now let's talk about something that astronauts have reported that's both beautiful and deeply disturbing. The overview effect. The overview effect is what happens when you see Earth from space for the first time. Astronauts describe it as a profound, often emotional experience that changes how they see themselves and humanity. From space, you can see the entire Earth. You can see it as a small, fragile sphere floating in an infinite void. You can see how thin the atmosphere is, just a delicate layer that looks like it could be scraped off with a fingernail. You can see the lack of borders, the way all of humanity is crammed onto this tiny rock with nowhere else to go. Many astronauts have said it made them feel small, insignificant, but also deeply connected to everyone else on Earth. All of human history, every person who has ever lived, every war, every love story, every triumph and tragedy, has happened on that little blue marble. But here's where it gets disturbing. That perspective doesn't leave you. Astronauts come back changed. Some report depression, anxiety, a sense that nothing on Earth matters anymore. How do you go back to worrying about traffic or bills or what's for dinner when you've seen the entirety of human existence as a speck of dust in an uncaring universe? The overview effect forces you to confront something most people can avoid their entire lives. Our cosmic insignificance. We like to think we matter, that our lives have meaning, that what we do is important. And on a human scale, those things are true. But from the perspective of space, from the perspective of the universe, we're nothing. The entire Earth could be destroyed tomorrow, and the universe wouldn't notice. Wouldn't care. Would continue on exactly as it had before. In a few billion years, the sun will expand into a red giant and engulf the Earth, burning away every trace that we were ever here. And even that is nothing on a cosmic scale. The universe is 13.8 billion years old. Human civilization has existed for maybe 10,000 years. Modern technological civilization for less than 200 years. We've been here for 0.0007% of the universe's existence. We're not even a rounding error in cosmic time. And the universe will continue for trillions upon trillions of years after we're gone. Eventually, all the stars will burn out. The universe will become cold and dark. Matter itself might decay. Reality will end not with a bang but with a whimper, in what physicists call the heat death of the universe. Everything we do, everything we build, everything we create will eventually be erased as if it never existed. That's what space teaches you when you really look at it. We are temporary patterns in an ocean of chaos, and someday, we'll dissolve back into that chaos like we were never here. The accidents we can't prevent. Let's talk about the disasters that have already happened in space, because they remind us how dangerous it really is out there. In 1967, 3 astronauts died in Apollo 1 when a fire broke out in their capsule during a ground test. The pure oxygen atmosphere meant the fire spread in seconds. The hatch was designed to open inward, and the pressure from the fire made it impossible to open. They burned to death, trapped, screaming for help that couldn't reach them in time. In 1971, 3 Soviet cosmonauts died when their Soyuz 11 capsule depressurized during re-entry. A valve opened accidentally, and all the air rushed out. They had no spacesuits. They suffocated in about 40 seconds. When the capsule was opened, the recovery team found 3 bodies, still strapped into their seats. In 1986, the Space Shuttle Challenger exploded 73 seconds after launch, killing all 7 crew members. The explosion was caused by an O-ring seal that failed in the cold weather. The solid rocket boosters continued to fire for another 37 seconds, tumbling through the sky. The crew cabin stayed intact during the explosion and fell from 48,000 feet into the ocean. Some of the crew might have been conscious during the fall. They had about 2.5 minutes to know they were going to die. In 2003, Space Shuttle Columbia broke apart during re-entry, killing all 7 crew members. A piece of foam insulation had struck the wing during launch, creating a hole. Hot gases entered the wing during re-entry and the shuttle disintegrated. The crew probably lost consciousness quickly when the cabin depressurized, but we'll never know for sure. These aren't ancient history. These are modern disasters. We've gotten better at space travel, but it's still incredibly dangerous. Every launch is a controlled explosion. Every spacewalk is a chance for equipment failure. Every mission involves thousands of things that could go wrong, any one of which could be fatal. And those are just the public disasters. There have been close calls we barely know about. Fires on space stations. Near misses with debris. Equipment failures that almost killed people. Astronauts have reported seeing their spacesuits starting to fill with water during spacewalks, nearly drowning them inside their helmets. They've had cooling systems fail, causing them to overheat. They've had communications go dark, leaving them alone outside their spacecraft with no way to call for help. Every person who goes to space knows they might not come back. They've all signed up for a dangerous job, and they do it anyway because they believe it's worth the risk. But the fact that we lose people, that we've lost people and will lose more people, shows just how hostile space really is. We're fighting against an environment that doesn't want us there, that's actively trying to kill us every second we're in it. And sometimes, it wins. The scale that breaks understanding. Let's talk numbers for a moment, because sometimes the sheer scale of space is what makes it most terrifying. The Sun is about 93 million miles from Earth. Light from the Sun takes about 8 minutes to reach us. That means when you look at the Sun, which you shouldn't do directly, you're seeing it as it was 8 minutes ago. If the Sun exploded right now, we wouldn't know for 8 minutes. Neptune, the farthest planet in our solar system, is about 2.8 billion miles from the Sun. Light from the Sun takes about 4 hours to reach it. The Voyager 1 spacecraft, which has been traveling for over 45 years and is now in interstellar space, has only gone about 14 billion miles from Earth. That's still inside our Sun's influence. It's only just now leaving our solar system. The nearest star to us, Proxima Centauri, is 4.24 light-years away. That's about 25 trillion miles. At the speed of the Voyager spacecraft, it would take about 73,000 years to get there. Our galaxy, the Milky Way, is about 100,000 light-years across. That's about 600 quadrillion miles. To put that in perspective, if you could travel at the speed of light, you could circle the Earth 7.5 times in 1 second. At that speed, you could reach the Moon in 1.3 seconds. You could reach the Sun in 8 minutes. You could cross our entire solar system in about a day. And it would still take you 100,000 years to cross our galaxy. The Andromeda Galaxy, our nearest large neighboring galaxy, is about 2.5 million light-years away. That's 15 quintillion miles. Even at the speed of light, it would take 2.5 million years to get there. The observable universe is about 93 billion light-years across. That's because the universe has been expanding for 13.8 billion years, and space itself is expanding faster than light can travel through it. But here's the really mind-breaking part. That's just the observable universe. The actual universe is probably much, much bigger. Possibly infinite. There are parts of the universe we will never be able to see, no matter how long we wait or how good our telescopes get, because they're so far away that light from them will never reach us. Let me give you a sense of scale another way. If our sun was the size of a basketball, Earth would be about the size of a peppercorn about 26 feet away. Jupiter would be about the size of a golf ball about 135 feet away. Neptune would be the size of a peppercorn about 780 feet away. On that same scale, the nearest star would be another basketball about 5,200 miles away. That's roughly the distance from New York to London. And our galaxy? On that scale, our galaxy would be about 206 million miles across. That's more than twice the distance from Earth to the Sun at actual scale. These numbers are so big that they stop meaning anything. Your brain can't actually comprehend them. You can say 25 trillion miles, but you can't really understand what that means. You've never experienced distances like that. Nothing in your evolutionary history prepared you to think on those scales. And that's terrifying because it means we're trying to explore and understand something that's literally beyond our capacity to fully grasp. We're ants trying to understand the ocean. We can learn facts about it, but we can't truly comprehend it. The unknowns that lurk. Now let's talk about the things we know exist but don't understand. Black holes, for example. A black hole is a region of space where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse, crushing their mass into an infinitely small point called a singularity. Near a black hole, weird things happen. Time slows down. Space gets warped. If you fell toward a black hole, from your perspective you'd cross the event horizon in finite time and hit the singularity. But from the perspective of someone watching from far away, you'd appear to slow down and freeze at the event horizon, never quite falling in. And what happens at the singularity? We don't know. Our physics breaks down. The math gives us infinities, which usually means we're doing something wrong. Some physicists think the singularity might be a point of infinite density. Others think it might be a portal to another universe. Others think it might not exist at all and that quantum mechanics saves us from true infinities. We don't know. We can't know because we can't see inside a black hole. Anything that crosses the event horizon is gone forever, unable to send any information back to us. But black holes get weirder. Some of them spin, which creates a region called the ergosphere where spacetime itself is dragged around. If you were in the ergosphere, you couldn't stay still. Spacetime itself would be moving, carrying you with it. And some black holes are supermassive, millions or billions of times the mass of our Sun. There's one at the center of our galaxy, Sagittarius A, that's about 4 million times the mass of the Sun. It's 26,000 light-years away, and it's constantly eating stars and gas and anything that gets too close. If you fell into a supermassive black hole, you might actually survive crossing the event horizon. The tidal forces would be weaker than near a smaller black hole. You could cross the point of no return and not even realize it. You'd just keep falling, watching the universe outside speed up and fade away, until eventually you'd hit whatever's at the center. And we have no idea what that would be like. But wait, there's more. Scientists think there might be another kind of black hole. Primordial black holes. These would be tiny black holes, maybe as small as an atom, that formed in the early universe. They could be drifting through space right now. One could pass through your body and you'd never know it. Unless it passed through your brain and killed you instantly. And then there are theoretical objects even weirder than black holes. White holes, which are like black holes in reverse, spewing out matter and energy. Wormholes, which might be shortcuts through spacetime but would probably be unstable and would collapse before you could use them. Naked singularities, which would be singularities without event horizons, visible to the universe. Weird bubbles in spacetime where the laws of physics might be different. The universe is full of objects and phenomena that we barely understand or don't understand at all. And any of them could be dangerous in ways we can't predict. the enemy that never sleeps. Let's talk about something more immediate. Space debris. Right now, there are about 34,000 pieces of space debris larger than 10 centimeters orbiting Earth. That's debris we can track. There are an estimated 900,000 pieces between 1 and 10 centimeters, and 128 million pieces smaller than 1 centimeter. Every one of those pieces is moving at orbital velocity, which means at least 17,500 miles per hour. At that speed, even a tiny piece of debris can cause catastrophic damage. In 2016, a tiny piece of space debris hit the International Space Station and chipped one of the windows. It was probably just a paint fleck, smaller than a grain of sand. It created a divot in the multi-layered glass that was 7 millimeters across. A piece of debris the size of a marble could disable a satellite. The size of a softball could destroy a spacecraft and kill everyone inside. And it's getting worse. Every time we launch a rocket, we create more debris. Spent rocket stages, fragments from explosions, pieces that break off during launch. And when two pieces of debris collide, they create more debris. Smaller pieces, but more of them. This is called Kessler syndrome, and it's a nightmare scenario. If we create enough debris in orbit, collisions will start to cascade. One collision creates more debris, which causes more collisions, which creates more debris. Eventually, Earth could be surrounded by a shell of debris moving at orbital speeds, making it impossible to launch anything through it. We'd be trapped on our planet, unable to access space, for decades or even centuries until the debris slowly fell back to Earth. Some scientists think we're already close to the tipping point. A few more major collisions and we might start the cascade. And there's not much we can do to stop it. We don't have the technology to clean up space debris effectively. We can track the big pieces and try to avoid them, but the small pieces are invisible until they hit something. Every spacecraft, every satellite, every space station is at risk. The International Space Station has had to maneuver to avoid debris dozens of times. Sometimes the warning comes with just hours to spare. Sometimes the debris is detected so late that there's no time to move, and the astronauts just have to hope it misses. We've created an enemy that never sleeps, never stops, and constantly grows. And it's surrounding our planet like a wall, threatening to cut us off from the stars we so desperately want to reach. The madness that space brings. Let's talk about what extended time in space does to the human mind. Astronauts on the International Space Station report strange dreams, more vivid than on Earth. Some report feeling a presence, like someone is watching them. Some report seeing flashes of light even with their eyes closed, caused by cosmic rays passing through their brains. On longer missions, the psychological effects get worse. Studies on people in isolated environments, like Antarctica research stations, show that people can develop something called third-quarter syndrome. About 3/4 of the way through a long mission, people hit a psychological low point. They become depressed, irritable, less able to work effectively. Now imagine that happening on a mission to Mars. You're millions of miles from home, trapped in a small spacecraft with the same few people for months. You can't go outside. You can't leave. You can't even call home without significant delays. And you start to crack. There have been experiments simulating Mars missions on Earth, where volunteers spend months in isolation in mock spacecraft. In one experiment in Russia, 2 crew members got into a fistfight. In another, a crew member tried to forcibly kiss another crew member. These are carefully selected, highly trained people, and even they couldn't keep it together under the stress. What happens if someone has a psychological breakdown on a mission to Mars? You can't send them home. You can't evacuate them. You can't even sedate them for months because you need everyone working. You're stuck with a person who might be violent, might be suicidal, might be completely detached from reality, and there's nothing you can do but try to manage them until you get back to Earth. And it gets worse. Some scientists are worried about something called space anemia. Extended time in zero gravity causes the body to destroy red blood cells faster than it creates them. This leads to anemia, which affects cognitive function. You start thinking more slowly, making mistakes, forgetting things. Combined with the isolation, the stress, the constant danger, and the cosmic radiation possibly damaging your brain, and you have a recipe for psychological disaster. There's a reason astronauts are some of the most carefully screened people on Earth. They have to be not just physically fit and technically skilled, but psychologically resilient in ways most people aren't. And even they struggle. Space doesn't just threaten your body. It threatens your mind, your sanity, your very sense of self. And unlike physical injuries, psychological damage can be invisible until it's too late. The economics that don't work now. Let's talk about something practical. Space travel is absurdly expensive, and it probably always will be. It currently costs about $10,000 per pound to launch something into low Earth orbit. That's $10,000 for every pound. A person weighs, on average, maybe 180 pounds. That's $1.8 million just to launch one person, not counting their life support, their food, their equipment, the spacecraft itself, the fuel for maneuvering, or anything else. SpaceX has brought costs down significantly with reusable rockets, but even their most optimistic projections put the cost at thousands of dollars per pound. That's still incredibly expensive. A mission to Mars with current technology would cost somewhere between $100 billion and $500 billion. That's for one mission. To establish a permanent base on Mars, to make humans a multiplanetary species, would cost trillions. Who's going to pay for that? Governments. Most countries can't afford their current space programs. Private companies. They need to make a profit, and there's no obvious way to make money on Mars. Mining asteroids might be profitable eventually, but the upfront costs are astronomical, and it might take decades to see returns. Some people dream of space colonies, of cities on Mars or in orbit. But the economics are brutal. Every single thing would have to be shipped from Earth at enormous cost, or manufactured locally with equipment that was shipped from Earth at enormous cost. The colony would need constant resupply missions. One accident, one crop failure, one equipment breakdown could kill everyone. Earth is a paradise compared to anywhere else in our solar system. It has breathable air, drinkable water, edible plants, a magnetic field that protects us from radiation, a stable climate, relatively speaking, and gravity that matches what our bodies evolved for. Nowhere else comes close. Living on Mars would mean living in underground bunkers to avoid radiation, wearing spacesuits every time you went outside, recycling absolutely everything because you can't get more, and knowing that any serious medical emergency would probably be fatal because you can't get to a hospital. Who would want to live like that? Maybe a few pioneers, a few adventurers. But enough to build a civilization? Probably not. The hard truth is that space might always be just a place we visit, not a place we live. The distances are too vast, the costs too high, the dangers too great. We might send robots, maybe even visit ourselves occasionally, but the dream of becoming a spacefaring species might be just that. A dream. And if we're stuck on Earth, and Earth is the only place humans can live, then any disaster that hits Earth could end us. We're putting all our eggs in one basket, and space isn't going to save us. The inevitability of death. Let's talk about the ultimate horror of space. The eventual death of everything. The universe had a beginning. About 13.8 billion years ago, everything that exists came into being in the Big Bang. Time, space, matter, energy, everything started then. And the universe will have an end. Current cosmology tells us that the universe will continue expanding forever, getting larger and larger, colder and colder. Stars will burn out. No new stars will form because all the hydrogen and helium will be used up. Eventually, every star will die, and the universe will be dark. But it doesn't end there. Over unimaginable spans of time, trillions upon trillions of years, even the dead stars will decay. Protons might break down. Black holes will evaporate through Hawking radiation. Eventually, there will be nothing left but a thin soup of particles spread across an infinite, expanding void, too far apart to ever interact again. This is called the heat death of the universe. It's the state of maximum entropy, where no energy can be extracted for work, where nothing can happen. It's not death in the sense that something dies. It's the end of the possibility of anything ever happening again. Every civilization that ever exists, every thought, every feeling, every achievement, every work of art, every scientific discovery, everything will eventually be gone. Not just forgotten, but physically impossible to recover because the information itself will have decayed into randomness. From the universe's perspective, it won't matter that we existed. it won't matter what we did or didn't do. In the end, everything returns to nothing. And here's the really disturbing part. We can see this coming, but we can't stop it. The laws of physics, as we currently understand them, make it inevitable. Entropy always increases. Energy always spreads out. Heat death is the final destination of everything. Some physicists hope that there might be loopholes, ways to escape to other universes, or ways to survive by becoming something we can't currently imagine. But those are just hopes, speculation. Based on what we know, everything ends. Space isn't just trying to kill us individually. It's set up so that eventually, everything dies. The universe itself is mortal, and when it dies, it takes everything with it. The mirror that shows us here's the final, perhaps most profound horror of space. It forces us to confront who we really are. We spend most of our lives distracted. We worry about our jobs, our relationships, our bills, what to have for dinner. We create dramas and conflicts to fill our time. We build civilizations and cultures and religions and philosophies to give meaning to our existence. But space strips all that away. When you look at the universe, really look at it, you see the truth. We are insignificant. We are temporary. We are accidents, cosmic flukes, patterns in the chaos that briefly became self-aware before dissolving back into randomness. Everything we think matters, doesn't. Not on a cosmic scale. The universe doesn't care about us. It doesn't even know we exist. We're not the center of creation. We're not special. We're just chemistry, briefly organized in a way that can think and feel and wonder why we're here. And the answer is, there is no why. We're here because the conditions happen to be right for life to form. That's it. No grand plan, no cosmic purpose, no destiny. Just chance. Space shows us that we're alone in a vast, hostile, uncaring universe that's actively trying to kill us. It shows us that our entire existence is a brief flicker in infinite time. It shows us that everything we build will crumble, everything we create will be destroyed, and everyone we love will die. This knowledge, this existential horror, is what astronauts experience when they see Earth from space. This is what the overview effect really is. The sudden realization that we're floating on a rock in an infinite void, and nothing we do will ultimately matter. Some people find this liberating. If nothing matters, then you're free to create your own meaning, to live however you want. But for others, it's crushing. It's too much weight, too much emptiness, too much truth. And you can't unknow it once you know it. You can't unsee what you've seen. You can try to go back to your normal life, to care about the small things, but part of you will always remember. You looked into the void, and the void looked back. Why we go anyway? So space is hostile. It's empty. It's silent. It's dark. It's full of things that can kill us in horrible ways. It shows us our insignificance. It promises no reward, no safety, no comfort. It will ultimately kill everything we are and everything we create. And yet, we keep going back. We keep building rockets, keep training astronauts, keep sending probes to distant worlds. We keep looking up at the stars and dreaming of what's out there. Why? Maybe because we're human, and humans don't know how to stop exploring. We've always looked at the horizon and wondered what's beyond it. We crossed oceans on wooden boats. We climbed mountains that killed most who tried. We went to the poles of our planet where everything is trying to freeze us to death. And now we're going to space. Maybe because despite everything, despite all the horror and danger, there's also beauty out there. The birth of stars in nebulae, the dance of galaxies, the rings of Saturn, the red dust of Mars. The universe might not care about us, but it's still filled with wonders. Maybe because we're the universe's way of knowing itself. We're made of star stuff, as Carl Sagan said. The atoms in our bodies were forged in the hearts of dying stars. We're not separate from the universe. We're part of it. And through us, the universe can look at itself and understand what it is. Maybe because even if everything ends, even if nothing ultimately matters, it matters to us right now. The fact that we exist, that we can think and feel and love, that we can reach out into the darkness and try to understand it, that's meaningful even if it's temporary. Or maybe we're just stubborn. Maybe we're so determined to survive, so unwilling to accept limits, that we'll keep pushing forward even when everything tells us to stop. Maybe that's what makes us human. The refusal to give up even in the face of cosmic horror. Space is terrifying. It's the most hostile environment we've ever encountered. It's trying to kill us in 1,000 different ways. It shows us truths about existence that many people would rather not face. It promises death and offers no guarantees of survival. But we're going anyway. Because we're curious. Because we're brave. Because we're foolish. Because we're human, and humans don't know when to quit. And maybe, just maybe, that's the most terrifying thing of all. Not the darkness of space, but the fact that we're willing to venture into it anyway, knowing full well what's waiting for us out there. We looked at the infinite, hostile, uncaring universe, and we said, let's see what happens. That's either the bravest or the most insane decision our species has ever made. And we're still not sure which. So now you know. Now you understand why space is truly horrifying. Not because of any single threat, but because of what it represents. The ultimate test of humanity's will to survive against an environment that doesn't just want to kill us, but that doesn't care if we exist at all. The next time you look up at the night sky, remember. Those beautiful stars are actually nuclear furnaces floating in an infinite void separated by distances so vast they might as well be unreachable. That darkness between them isn't empty, it's full of radiation, debris, and things we don't understand. And somewhere out there, maybe right now, something is happening that could end us all, and we'd never see it coming. Sleep well.